Look at this. IBM WebSphere MQ. Here MQ stands for message queuing or messaging and queuing. We can say it as message queuing or messaging and queuing. Anything is fine. IBM WebSphere MQ built on Java. It is platform independent. It supports 80 plus platforms. MQ is an IBM middleware message transport product. It enables communication between distributed applications over the network. As you know, MQ stands for message queuing. Applications exchange data as messages over the IBM MQ server. The MQ server is going to hold data as messages. Whenever remote service requests the data, it forwards in queuing fashion. Look at here. This is Windows host and this is Linux host Dinesh. On Windows host, an application is hosted. Its name is Business Service. On Linux host, an application is hosted. Its name is Business Operation. These two distributed applications wish to communicate each other by exchanging data. In between distributed applications, we configure an integration engine. It is IBM WebSphere MQ. IBM WebSphere MQ, known as an integration engine, it integrates distributed applications irrespective of the platform, programming language and protocol by providing an interface. It is MQ API. Programmers need to know implementation of MQ API. If they implement the MQ API, then program defines data as message and it exchanges with remote service. Look at here. Now my business service wants to exchange some data with business operation. Now my business service defines its data as message. MQ message consists two parts. MQ message consists two parts. They are MQMD header, payload. Payload known as message body. Payload known as message body. Here application inserts actual message data. This is the application defines data as message. It connects MQ server. It puts message on object Q. Q is an object in MQ series. It is a file and data structure. It holds messages as container. It is nothing but write here. It is nothing but write. Business service delivers its data as message to MQ server. In MQ server, message available on Q. If remote service available on online, it connects IBM MQ server. It gets message on Q. See here on MQ server, major operations are okay. It is nothing but write. Get is nothing but read. IBM MQ server, also known as store and forward mechanism here. Look at here. An application store data as message on MQ queue. Whenever remote service requests that data, queue has forwarded, right? MQ server here supports once and only once delivery and guaranteed delivery. It is just like passbook. Yeah, beyond, you know very well bank passbook, right? In bank passbook, what are the transactions we can see? Debit and credit only, right? If we deposit, they credit. If we withdraw, they debit. Once if we withdraw money on our account, the money no more, right? Here also the same. An application deposits data as message in MQ server. Whenever remote service gets the data no more. Okay. Once again, I repeat the statements. Listen me please. IBM WebSphere MQ built on Java. It is platform independent. It supports 80 plus platforms. It is an IBM middleware message transport product. It enables communication between distributed applications over the network. IBM WebSphere MQ, known as an integration engine, it integrates distributed applications irrespective of the platform, programming language and protocol by providing an interface MQ API. On MQ server, major operations are put and get. Here MQ server can route the data. It cannot transform the data. That means just it is store and forward mechanism beyond. And Dinesh, IBM MQ server is just store and forward mechanism. It is just like passbook. An application deposits data. When an application deposits the data will be available on MQ queue. Whenever remote service gets the data, queues will forward. Then no data at MQ server. Okay. I hope you are clear. See, your applications exchanging data as messages. The messages delivered to remote service in queuing fashion, one after other, right? Are you clear beyond the Dinesh?
Yes.
Good. Look at here, I will show you the same in the PPT. So what is message? I explained, don't worry. Message is collection of data or representation of data. Message consists two parts. They are MQMD, header and payload. MQ message is created by an application. MQ message is consumed by an application. As a MQ server, it can hold the messages until processed by the remote service. Look at here. We integrated two business services over the network by configuring MQ server. Now my business service sending its data as messages to MQ server. In MQ server, queue holds messages. Whenever remote service requests the data, queue forwards. The MQ server here supports once and only once delivery and guaranteed delivery. As you know, MQ message consists two parts, right? MQMD header and message body. Message body known as payload here. Application may insert XML data in message body. It may insert text data. It may insert binary data. It may insert anything. Whatever the data sender end application wants to exchange with the remote end application, the data application defines in message body. Okay. The MQMD stands for MQ message descriptor. It contains control data about the message, metadata about the message. Metadata is nothing but message ID, what it is, what is the message expiry, message persistence, message priority, this kind of data contained by MQ header. This whole message is created by MQ application. It is consumed by MQ application. Okay. This is sample MQ message here. This is sample MQ message. Here you can see message descriptor here to here. At last you can see the message body. In message body, application has defined text data. Here it can insert any type of data. Okay. You know very well database, right? So in DB engine we create tables to hold data as records permanently. Right, Dinesh? Dinesh, in DB engine we define tables to hold data as records permanently. Whereas in MQ server we define queues to hold data as messages temporarily. I hope you are clear beyond about it. Look at here, an application delivered messages to Q1, Q2. In between MQ server and DB engine, an application is defined, it is J2E application. It has to get data on MQ server and it has to insert data into the database. So it makes connection to both the resource managers. It starts two-phase commit, then it starts getting data on MQ server and inserting data into the database, right? See, your data available as message, the same data whereas in database inserted as record in the table. So if you compare IBM MQ server with the DB engine, it is easy to understand. Once if we insert the data into the database, until we delete, we can extract n number of times, right? Whereas in MQ server, once if we get the data no more. Okay? So programs here communicate by putting messages on queue. Your application is putting messages on Q1, which is ready by program B. This is here communication is one way between distributed applications. We can enable two-way communication also. Your application here putting request type message on Q1, it's getting reply type message on Q2. Application B getting request type message on Q1, it's putting reply type message on Q2. One-way communication, two-way communication is possible. Distributed applications can run at different times. No need to be available at the same time to each other to exchange message data. It supports synchronous communication and asynchronous communication. Both applications can available at the same time on IBM MQ server to exchange data, or they can run at different times. We can couple the applications loosely. Okay. No constraints on application structure. One-to-one communication MQ can enable one-to-many, many-to-one, many-to-many. Any type of messaging MQ server can enable between distributed applications over the network. No constraints on application structure. So what IBM says about MQ means once and only once delivery and guaranteed delivery. Okay. Let's see here. His name is Dinesh. Java is nothing but an object, right? No. MQ series built on Java. In MQ series, everything we define as an object. In MQ series, predefined objects are 7. Look at here. MQ predefined objects are 7. They are queue manager, queue, channel, listener, process, name list, and service. Listen me. MQ predefined objects are 7. They are queue manager, queue, channel, listener, process, name list, and service. To define name to MQ objects, MQ series allowed char set is A to Z capital, A to Z small, 0 to 9 digits. Allowed special characters are dot, slash, mod, underscore. See, we define unique names to objects. To define names to MQ objects, MQ series allowed char set is A to Z capital, A to Z small, 0 to 9 digits, dot, slash, mod, underscore. MQ series object names length can be less than or equal to 48 characters except channel here. Except channel. Channel name can have less than or equal to 20 characters. Look at here. Less than or equal to 48 characters. Less than or equal to 20 characters. This is only for channel name. Okay, except channel name. Rest of the MQ series object names length can be less than or equal to 48 characters. Okay. See, we have to administrate these 7 objects beyond. What is mean by administration? Create objects, delete objects, modify object definitions, restart services. Okay. These are all comes under administration only, right? So to administrate MQ objects, MQ provides predefined commands. MQ predefined commands are control commands, MQSC commands, and PCF commands. MQ predefined commands broadly categorized into 3 types. They are control commands, MQSC commands, and the PCF commands. As a WMQ system admin beyond, you don't work with PCF commands. As a WMQ system admin, you always work with control commands and MQSC commands. Control commands are around 25. MQSC commands are only 14. Control commands we execute at OS level. MQSC, here MQSC stands for MQ script commands here. MQSC commands we execute at MQ server level. Okay. Right. Let me introduce this one. As you know, hardware, right? Hardware operating system. What is platform? Hardware plus software, right? Of this hardware unit, I install Windows operating system. Now this platform is Windows platform. On Windows, we install Windows MQ, right? I install Windows MQ on this host. Once MQ is installed on Windows, it runs as a service. Runs as a service. On top of this, we host MQ objects beyond. Observe, please. Hardware, operating system, IBM MQ service. On top of that, MQ objects. Okay. Right. Here you are seeing 7 predefined objects, right? In these 7 predefined objects, queue manager is an initial object. It is first and foremost object in MQ series. Unless we create queue manager, we cannot create rest of the MQ predefined objects. Queue manager itself MQ server. Queue manager itself MQ engine. Queue manager is subsystem. It controls and holds all the MQ predefined objects. Look at here, Beyond and Dinesh. Once MQ is installed on Windows, it runs as a service. On top of that, very first we create Queue manager. Once Queue manager is created, we can create rest of the MQ predefined objects in its control. Now I create queue, channel, listener, process, name list, and the service. Okay. There is no queue manager, there is no rest of the MQ predefined objects, Dinesh. Yes, Beyond. Here you have to understand one more thing. It is queue manager is single point of contact to all the distributed MQ applications to perform put and get operations on MQ queues, right? When application wants to access the queue to perform either put or get, first it has to connect the queue manager. Then only it can access the queue, it can perform either put or get. It provides queuing services to the applications. Okay, listen me. Queue manager is an initial object. It is first and foremost object in MQ series. Unless we create queue manager, we cannot create rest of the MQ predefined objects. Queue manager is subsystem. It controls and holds all the MQ predefined objects. Queue manager itself, MQ server and MQ engine. It is single point of contact to all the distributed applications to perform put and get operations on MQ queue. It provides queuing services to the applications. Okay. Here control commands are like CRT MQM, STR MQM, END MQM, DLT MQM, DSP MQ BER, DSP MQ, DSP MQ INST. This kind of commands we can see. But whereas MQSC commands are normal English words. I will show you MQSC command. Look at here. Beyond MQM, beyond QM. Look at here. WebSphere MQ Queue Manager created, right? I described this command, don't worry. CRT stands for create beyond. M stands for MQ series. QM stands for Queue Manager. Create MQ series Queue Manager. On name beyond QM. Is it created or not? So created. Queue Manager itself, MQ server. So I have to start server. I started. Queue Manager holds rest of the MQ predefined objects, right? So to create rest of the MQ predefined objects or to administrate rest of the MQ predefined objects, now I am in Queue Manager control area. Is there any command prompt beyond? Look at here, cursor blinking.
Yes.
Is there any command prompt?
No. It's just blinking.
Yeah, it is a special console. It is special console. It is Queue Manager control area. Or it is Queue Manager control area. Or we can call it as Run MQSC console. We can call it as WMQSys admin interface. MQ admin always works at here. Okay. At this console, I am trying to execute XYZ. At this console, valid MQSC commands are as listed below. User defined commands you cannot execute at this console. So here commands are normal English words, right? How many they are? Totally 50. So if you want to quit queue manager control area, the command is end. Now you are out of the queue manager. So if you want to get into queue manager, you can get into that. If you want to quit queue manager control area, you can quit. Okay. At this console, you can execute only MQSC command. They are predefined. Okay. Yeah, Linux also the commands are same. 1 minute please. MQSC commands. These are all MQSC commands. Right? Now I connect the Linux host here. I connect the Linux. Connect the Linux host. 1 minute please. See, command is the same. So the disk space not available. Let me delete on queue manager. Yes, DLT MQM SRC QMGR. I will show you commands here. Don't worry. Let me create queue manager. CRP MQM followed by queue manager name. Queue manager is created. Here you can read the statement. WebSphere MQ queue manager created. Now start queue manager SDR MQM followed by queue manager name. Look at area. This is dollar prompt, right? Yeah, beyond and Dinesh. Here you can see the dollar prompt. Now I hit the enter. Is there any dollar prompt? Your cursor is available, right? At cursor, is there any dollar prompt? No. Can you hear me?
Yes.
Okay, right. I'm trying to execute something. What it's saying, syntax error detected. Valid MQSC commands are as listed below. Okay. IBM MQ predefined objects, IBM MQ predefined command are consistent between platforms. Okay. Whereas in AS400, additionally one character is added, except that commands are same. Nothing see, if you see the outcome of the MQ series, what is 7 objects, right? 40 predefined commands. Major operations are put and get. Data comes as message to MQ server. The data MQ server holds an object. This is outcome. 7 objects, 40 predefined commands. Major operations are put and get. Data comes as message to MQ server. The data stored in object queue. Now I will show you some MQ API implementations. How programmers implement MQ API. Here, as a WMQ system admin, you don't implement MQ API. Programmers are going to implement MQ API. Can you read out this, Dinesh?
A sample program that asynchronously puts messages to message.
That means this is the program. The programmer is going to develop in C programming language. Okay. IBM WebSphere MQ provides interface it is MQ API to integrate the applications, right? See, to the C programming language, WebSphere MQ provided MQ API and header file. See, programmer has included that header file. He started implementation. So you can see here, what is the very first call?
Connecting to
What it is? Connect to queue manager. Program must connect the queue manager to open queue to perform put and get operations. Here application makes connection to the queue manager. To make the connection to queue manager, what is the API call? It will execute MQ con call, right? In MQ perspective, we say it as call. In C perspective, it is function. In Java perspective, it is method, right? MQ con of queue manager name. Make the connection to queue manager. So after that, application has to open the queue, right? Queue is a file here. Application must open the file to perform either put or get. Put is nothing but write, get is nothing but read. See, if I open this file, then only I am able to read this data. If I don't open this file, I cannot read this data, right? If I want to insert the data in file, I must open the file. Here queue is a file, so application must open it. So to open, application executes MQ open call or MQ open function on queue name. Yes, after that it defines it, read lines from the file and put them to message queue. So this is sample program. We provide the data to this program, then it creates the message. After creating the message, to put on queue, it executes MQ put function. Okay. After that, it will close the queue. Close the target queue if it was open. Yes, the call is MQ close. After that, application disconnects. See, here easy to remember, connect, open, perform, either put or get, then close and disconnect, right? In this sequence only, all the MQ applications will execute operations on MQ server here. Connect, open, perform, either put or get on object queue, close object queue and disconnect. Okay. So this is MQ API implementation here. This implementation is handled by programmers. We don't handle. As a WMQ system admin, we install WMQ, we create MQ predefined objects, we grant and revoke authorities to MQ application user IDs on MQ predefined objects to allow and to prevent applications to access objects. Okay. At the same time, you can see here Java program also, sample Java program. IBM WebSphere MQ provides MQ API as jar file to Java programming language. So Java programmer keeps the jar in his class path, is going to import all the MQ API packages. Yes, beyond, can you read this statement in the main method?
Create a connection to the queue manager.
Yes, this is OOPS language, right? So he creates an object on a class. So MQ queue manager is the class. To this class he defines an object. Here this is the constructor. To this constructor he passed queue manager name as input. That means to which queue manager this program has to make the connection. That queue manager name he provides in constructor. After that, please read out this.
Now
Application
specify
made
the
a
queue
connection to queue manager. So it has to
Yes,
open the queue. To open the queue, this is the method it will use. So can you read out this?
MQ define a simple WebSphere MQ message.
So he is going to define some method to create the message. So can you read this?
Put the message to the queue.
Yes, queue dot put. Queue dot put. If application wants to get the message of the queue, queue dot get. If application wants to close the queue, queue dot close. If application wants to disconnect from the queue manager dot disconnect, right? Connect, open the queue, create the message, perform either put or get, close the queue, disconnect from MQ server, right? So this is how programmers implement MQ API. Then programs are capable to create messages. They are capable to make the connection to queue manager, and they perform put and get operations on MQ queues. Okay.
Madhu, I have a quick question here.
Yes,
Is that queue manager concept in the TIPCO messaging services also?
Yeah, TIPCO also can connect queue manager, it can send the messages. Shift messages, right?
The reason I was asking is, I mean, few years back I worked on one application where we are connecting to TIPCO EMS, Enterprise Messaging, ESP.
Okay.
So there I remember we are talking to queue directly. I don't remember exactly, but as far as I remember, we are directly opening the connection and putting the message. But I wanted to confirm, is there a queue manager concept in TIPCO also, or is it specific?
In TIPCO no queue manager. In TIPCO no queue manager.
Okay.
In TIPCO no queue manager.
Okay.
The mechanism is the same. The mechanism is the same, but objects are different.
Okay.
Mechanism is the same, but objects are different.
So in Java we have JMS, right? So for connecting to messaging servers.
Yes,
so
they are going to map the queues. They are going to map JMS queues to MQ queues. Queue is nothing but file here. JMS queue means it creates a file. It loads the data to a file. The file is read by some other program. That's it.
Okay.
Okay.
JMS API.
MQ queues. Whatever the data application belongs to JMS queues, the data reflected to MQ queues. Yes, please.
So we can use JMS API instead of MQ API here? Like the sample program?
You can use, but to use JMS, there is some dependencies are there while integrating different types of applications over the network. Okay, here the MQ server is able to integrate applications irrespective of the platform, whereas in JMS some dependencies are there. That is the only thing.
So do you cover that module, like how we can?
Yeah, JMS queue map the MQ queues. I will show you. Don't worry.
Okay. And also, like, do you cover difference between 7 and 8? Because actually,
all the differences we discuss here. See, from 7.0.1.0 in MQ series, multi-instance queue manager configuration possible. From 7.0.1.6, multiple MQs can coexist on a host. Okay, from 7.1.0.0, they newly introduced channel authentication records. From 7.5.0.0, they introduced FTP. They introduced in 7.1 itself the telemetry. So telemetry not a problem. At the same time, in 7.5 some trusted, related, advanced features they introduce. They completely moved PubSub to MQ series from 7.5. All the features we discussed in that, don't worry.
Okay, so I think PCF commands, so to create dynamic queues, do we use PCF commands? Or
PCF commands are used by MQ applications to create dynamic queues in MQ server at runtime. Okay. So for that required model queue object definition we create in Queue Manager, we provide it as input to the program. Okay. So programs use PCF commands to administrate MQ objects. Sample programs. I will show you sample programs. But to understand how to implement, see, here itself you can find the sample program, PCF program. Don't worry, see PCF, right? PCF samples here available. See PCF underscore phq.java, right? Okay. So go through this. So how programmer used PCF command to create queue.
okay,
Queue name mandatory. See, create the PCF message type for the create queue. Okay. So what you do? This is just like Java. It is Java only, right? In Java, we are using the commands. Okay. So you can go through all these programs. Okay, how to delete queue using PCF command. See PCF delete queue.java. This is one program. Here you can see some commands, PCF command. I will show you. See here, what it is?
okay. Delete.
Delete queue of PCF CM. Okay. That means PCF CM is the object, it is a variable, right, to this class. PCF underscore common methods. PCF CM equal to new PCF underscore common methods. Okay. Argument means we are going to provide queue name as input to this. So delete queue of queue name. So the queue is deleted, right?
Will you cover what exactly we can do with PCF commands in the course?
Yeah. Why not? Why not? Definitely.